A race car is driving on a semicircular racetrack. Its velocity at several points along the track is shown below. It's in this figure. Which diagram below could depict its acceleration at the corresponding points? So let's take a look at each of these diagrams. So it's moving in a circle. So we know that it's going to have an acceleration towards the center of the circle to keep it moving in the circle. This is the centripetal acceleration or the radial acceleration. And that is equal to the velocity squared over the radius. So if we take a look, we can immediately eliminate A because there is no acceleration pointing towards the center that's keeping it moving in a circle. And if we look at this, we'll also notice that the racing car is accelerating because the magnitude of the velocity vector is increasing at each following point. So we can also get rid of B because this is simply the acceleration. This is the only acceleration in B is the centripetal acceleration. So there's no tangential acceleration that's allowing it to speed up along the circle. So it must have a tangential component. So the acceleration must have a tangential component that's tangent to the circle for the race car to be accelerating like this. And we can also eliminate C because if we look at this, there is no tangential acceleration in this either. So it's not going to be C. So that leaves us with either D or E. Now, that comes down to this equation because both of these have a tangential acceleration component and both of these have a radial or centripetal acceleration pointing towards the center of the circle that's keeping the car moving in a circle. But if we look at this equation, we'll notice that the centripetal acceleration is proportional to the square of the velocity, which means that as the tangential velocity increases, the centripetal acceleration must also increase. So if the tangential velocity increases, the centripetal acceleration must also increase to keep it moving in the circle. So the radius is constant, but the velocity of the car is increasing. So the acceleration must also be increasing to keep it moving in the circle. So the correct answer would be D, since it has the tangential component to the acceleration that's allowing the race car to accelerate. And it has the component, the centripetal acceleration, that's keeping it in the circle. And that is how you would solve this problem here.